Hi students, welcome back to Physics for All YouTube channel. In today's session, I am going to explain you about the last topic of the semiconductors unit, that is direct band gap and indirect band gap semiconductor. Okay, now in direct band gap semiconductor, first of all we have to know what is the meaning of valency band and what is meant by conduction band. Okay, first of all I will explain about the definition of valency band. Already I have given explanation for the valency and conduction band. If you are having any doubt, you go back this YouTube channel and refer the origin of energy bands or energy band classification based on the conductor, semiconductor, insulator. You can go back that topic, you will get the clear idea. Okay, anyhow I am going to explain you about the valency band definition right now. The band which is filled with the valency number of electrons, that band is called as valency band. Okay, now if we can apply energy to the electrons in the valency level, then electrons in the valency band absorb that energy, they excited to the higher level. These higher levels are known as conduction. Higher levels are known as conduction band. This is about the valency band and conduction band. If energy gap present between the valency band and conduction band, that gap is known as forbidden. That gap is called as forbidden energy band. This is about the definition of valency band, then definition of conduction band and definition of forbidden energy band. Now coming to the present topic, that is direct band gap semiconductor. Okay, now in the direct band gap semiconductor, now this is a valency band. I am going to consider in the form of this curve. Okay, now this semiconductor contains all holes are available inside of the valency band and all electrons are available in the conduction band. Okay, now this is known as conduction band, it is known as valency band. Okay, you observe the valency band and conduction band clearly. Now we can say this position is called as maximum. This position is called as maximum of the valency band. Similarly, this position is called as minimum of the conduction band. Okay, if you observe the diagram carefully, the electrons in the conduction band can combine with the holes in the valency band. Wherever you can observe such type of recombination, such type of semiconductors are known as direct band gap semiconductor. In another way, what we can say, the semiconductors where you can observe maximum of the valency band exist on the top of the minimum of the conduction band. Wherever you can observe such type of semiconductors are called as direct band gap semiconductor. So what happened if it looks like this? Because of this reason, what we can say, the free electrons at the bottom of the conduction band which are minimum, these minimum electrons can combine directly with the holes in the valency band. Because of this reason, due to the recombination of free electrons and holes, there we can observe the conservation of momentum. So because of conservation of momentum, across the junction what we will observe, energy is emitted in the form of radiation. Here you have to understand about the important point. It is in the case of the semiconductor, energy is emitted in the form of photons. Okay, now the color of the emitted light, completely depending on the energy gap exists between the valency band and conduction band. This is about the definition and process happening inside of the direct band gap semiconductor. Example for such type of semiconductors are gallium arsenide semiconductor or gallium arsenide phosphate semiconductor diodes. Also you can consider light emitting diode. These are the example for the indirect band gap semiconductor. In the case of the direct band gap semiconductor, depending on the energy gap between the valency band and conduction band, the color of the photons emitted is going to change. This is about the direct band gap semiconductor. In a similar way, we can go for the indirect band gap semiconductor. If you can observe the diagram, the semiconductors where will not observe maximum of the valency band, which cannot lie on the minimum of the conduction band. This is shifted by k vector. Wherever you can observe, such type of semiconductors are known as indirect band gap semiconductor. Because of this reason, the holes in the valency band cannot recombine directly with what electrons in the conduction band. Because of this reason, due to the recombination of electrons and holes across the junction, indirect recombination is going to take place. Because of this reason, across the junction, energy is going to emit in the form of heat. This is about the indirect band gap semiconductor. Example for the indirect band gap semiconductors are silicon and germanium based diodes are nothing but ordinary p-n junction diodes are the example for the indirect band gap semiconductor. This is about direct band gap and indirect band gap semiconductor. In the examination, this question can be asked like as follows: distinguish between direct band gap and indirect band gap semiconductor. Or they may also ask like that, what are the differences between the direct band gap and indirect band gap semiconductor? They can ask like this, but anyhow this topic is very important. If you watch this video, if you are having any doubt, you ask me in the form of comment. I will explain you